This conference will now be recorded.
Star. Let me explain you what is the concept of star here. In C language, I write int A. Star A is the pointer to A. Wherever A is stored in my memory, in my laptop, somewhere A is stored, right? When I'm running the code, pointer to that memory, the address where it is present is called as the pointer. The same concept in SV is called as handle. But you don't have to use star. You just use the same name, it gets treated as a pointer. It also gets treated as a value based on how you use it. So one of the commonly used concept is what? Memory is allocated once, handle is passed everywhere. There are other concepts like all data in system Verilog should be viewed as a memory allocation. Name of the variable being the handle. Okay, I think that's fine. There are a lot of keywords in system Verilog. Keywords should not be used for data declaration, like string cover I should not do, because cover is a system Verilog language keyword. Okay. Are you familiar with dot convention in Verilog language? Means XMR. You write M1 dot, M2 dot, M3 dot count. What is this called as? Cross module. In cross module reference, there is a count variable present where? Inside M3. Where is M3 instantiated? Inside M2. M2 is instantiated inside M2. So in that context, to access the count, we have to write M1 dot, M2 dot, M3 dot count. That is called as cross module reference. Similar to that XMR in the Verilog, system Verilog also uses dot convention for accessing the data variables in a hierarchy. Even in system Verilog, we can use the similar concept of XMR. Dot is also used to access the members of object, structures, unions, interface, and modules. We'll discuss more of that. It can also be used for backdoor access. Let me not confuse you with too many things. Okay, let's now move on to the means we'll touch upon all these concepts maybe a few weeks later. We'll discuss that. Okay. Comments, you know, right? You have to write comments. One line you write as a double slash, multi lines you put in this one. Okay. You need to learn some good coding practices. If you ask me why are you skipping many things, time to time I feel that some of them will make learning complicated for you at this stage. So I skip those. I will keep it for a later session. Initially, probably 6 months back, I would have felt, okay, let me cover all that. But now I feel that it's not really required. So we should only focus on what is relevant for this week of training. So we'll only do that. So let's focus on good coding practices. Tell me, what are the good coding practices? If I have to tell you one of so some of the good coding practices are like file name and the class or module name should match. You keep top.sv, you keep module top. That is one thing. What else could be the other things? Use proper indentation. What else? Okay, let's anyway read through that. Okay. Always spend little more time, one additional minute to do proper indentation. See, many times what happens when students do the coding, their code will not be properly indented. Everything will be in random starting positions. So even if you see this is indented, this is indented by one tab. This is also indented by one tab. So it's easy to understand. Okay, what is meant by indentation? The code below current block should be one tab space shifted. Anything you code between begin and right, inside that code should be shifted by one tab space. General tab space is how much? 4 spaces. When working with a large code, I mean bigger code, always use this kind of convention. Are you familiar with this? Probably no. No. Okay. Uh, Use this one for opening a line, this for closing a line. Okay, I'll explain you. You have function new. I'll explain that through one example. Take this piece of code. Okay. Can you notice this code once? What am I doing? Wherever something is starting, I'm keeping a opening flower bracket. Wherever something is ending, closing flower bracket. Wherever function is starting, opening flower bracket. Wherever function is ending, closing flower bracket. Begin is there, closing flower bracket. End is there, opening and closing. If I click here, see if I'm keeping my cursor here, where is the other highlighting happening? Line number 13. When I keep here, line number 14. When I keep here, so automatically GVim has this ability, this feature, not ability, feature, where it identifies which one is the closing bracket. Many times this is a requirement actually. The codes that you have worked on are very simple, 50 lines, 100 lines. So you don't really find a need because you can see all the code in one go. If you just look at it, you will see all the code. But in complex projects, the code will be 1,000+ lines. In those cases, we have to have the indentation. I mean, this kind of opening and closing, which makes it easy for us to know where it is starting, where it is ending. Okay, for example, even if this line is here, where is it ending? 43. It's ending in line number 43. I want to know where this class has started actually. I want to know where this class has actually started. Do you know which line? You don't know, right? All you have to do is click your cursor there. Percentage you have to do. How do you get percentage in keyboard? Shift 5. It will take you to that point. Now I want to know again where is the end class is present. Where is this definition is ending? What should I do? Again. These are some small techniques which helps you. Again, you see I'm on line number 14. Where should I go? 17, 17, 17. Now you may ask me, what is this double backslash? Tell me why. What is this double backslash? Comments. Otherwise, what will happen is, if I don't use comments, it will also become part of code. Is it correct code now? If I use flower brackets without double comments, double slash, that's the reason we are using double slash. Actually, we want flower brackets only, but double slash is only to make sure that it is treated as a comment. Now, if you understand, when working with a large code, always use this opening line and closing line. Please read this once. Okay. So always you can set the tab stop to either 4 spaces, 2 spaces, or 8 spaces. And I have asked you to update the VimRC. Why? Because every day you use GVim. When you use GVim every day, you should be very good with GVim. Right? For example, I use laptop every day. I should know some of the important features of the key shortcuts, how to work with laptop easily. Same way, GVim also should be very good. Then your programming becomes easy. Okay. Next. We have already discussed the concept of constructs and pre-implemented methods. So I have explained you the concept of pop friend, pop back, all those things. Don't think that we have completed the queue. We will be discussing queue as a separate topic. Here idea is to explain you that there is a concept called as constructs and pre-implemented methods. Next. In the yesterday's session, if you remember, we have discussed about some few examples like how to implement a function. Point is, I was telling you that in system Verilog, it is more important to know the prototype of the function. For example, this function is there. How is the return happening? As a return argument, not as an output argument, right? So how to use it? P equal to add Q comma R. P equal to add of Q comma R, because output is a return. Same thing if I do like this. Can you do that PQR addition? If this is the new function, can you write the logic to add Q comma R and put it into P? Can you please write it in your notes? Did you understood my question? Instead of that, I have changed my function definition here. Input A, input B, output C. So what does this function will do? C equal to A plus B. Now, I want you to show me how you will use the add function. Can you please write it? It's just a one line I want to see. Sorry. Please write it. The way it is obvious, it's not obvious for everyone. So how will you do? Add QRP. P equal to Q plus RB you have to do. So first you have to pass what? QRP. It is not PQR. Got the idea? So you need to know where is the input position, where is the output position. Accordingly, we are passing QRP. Now, are these two same? They are different, right? Why they are differing? Because our function has been defined differently here, differently here. So whenever you use a function, you should know the prototype of the function. Whenever you use the function, you should know the prototype. So I don't really have to bother about what is there in this code. Only thing you need to know is what? How the first line looks like, which is called as prototype. Once you know the prototype, you know how to use that. So in system Verilog, that is what is more important. If you are using pushback, how to use pushback. If you are using put method, how to use put method. The good part is tool will correct you. If you do mistake, tool will tell you that you are doing wrong here. It will tell you that this is not correct way. Then you can correct it. Now tell me, if this is the case, what arguments will you pass? I want to do the same operation. You see, function is little different here. I want to do this operation. In what order I will pass the arguments? Tell me. PQR. Why? Because output is first, inputs are next. Whereas here output was last. So that order also you have to take care. Why these are important? Because these look very obvious, but when you use it, you will end up doing mistakes. If you interchange the order, tool will not correct you. If you instead of PQR, if you pass QRP, tool will not correct you. Okay. So you have to be careful about this. You know the concept of connection by name, connection by position concepts, right? Clear, right? So even inside the function, you can do connection by name, connection by position also. this is about some of the fundamentals of the language. Now we'll start with the new topic in system Verilog. We'll start with arrays. Okay. We are going to divide our system Verilog data types into two categories. The basic type of data types like arrays, integer, int, string, some of them, which we will focus in next 1-2 weeks. That will be sufficient for us to learn the object-oriented programming. Once that is done, then we'll go to the advanced data types. Okay. Right now, we will focus on the arrays and basic data types. So you all know what is an array. So I'm not going to really do everything from scratch. Okay. Only one thing you need to remember is vector in Verilog. When you come to system Verilog, it is called as vector. Array in Verilog is called as whatever term vector we used to use in Verilog, it is called as what? Packed array. Whatever term array we used in Verilog, it is called as what? Unpacked array. Whatever we did for vector, all those things apply for packed array because only the name is changed. Let's say what vector operation you can do, addition, multiplication, subtraction, everything you can do. You can do all that with packed array. What all things we did with array in Verilog? Same things you can do with unpacked array. It's just the name change, that's all. The fundamental behavior is completely the same. Some improvements are there. What is improvements? I'll tell you. In Verilog, integer, int array. Is it possible? It is not possible. In SV, it is possible. Same line, if you write in a system Verilog file, it will work. If I have one file like sample.v, it becomes what file? Verilog. There I cannot write this. It won't work. Instead of writing sample.v, if I write sample.sv, then it will work. So it understands that as soon as you write sample.sv, it understands that you are developing a system Verilog code.
Monitoring whatever is happening.
So it will start following the system.
Monitoring and whatever is the signals being given to the DLT, this component has a job of saving them so that that data can be analyzed. If I'm writing,
yeah, I think let's understand. So arrays in system Verilog are two types. One is static arrays, one is dynamic arrays. Static array is only one type is there, which is fixed size array. So whether you use static array, whether you use the term fixed size array, both refers to the same thing. That is what we have discussed in Verilog. The static arrays is what we have discussed in Verilog. In Verilog, there is no concept of dynamic array. The dynamic arrays are three types. Dynamic array, queue, associative array. The term dynamic array means any array whose size can be increased, decreased, deleted. That categorized into dynamic array. Now all these are those types only. A dynamic array itself is there, which can be increased, decreased, deleted. Queue, associative array, all this. So in the following slides, we'll be talking about these arrays. We'll be learning how to work with these arrays. If I take static arrays, that is fixed size arrays, size is allocated at the compile time. It can't be changed during the runtime. Do you understand the difference between compile time and runtime? Compile time means what? The time where you have done the coding. When you coded itself, the memory size gets fixed. When code gets compiled, right? Vlog, when you do, that time itself, the memory gets allocated as 10 integer spaces, 8 integer spaces, that much amount of memory. That is what we call as compile time. What is meant by runtime? See, when you are running memory example, you are doing write to a memory, read to a memory. That is all runtime. Because once you start the run -all, whatever starts, it is called as runtime. First of all, does everyone understand what is compile time? What is runtime? Compile time is the time where you compile, vlog. Runtime means the thing once you start run hyphen all, whatever happens after that. Okay. So how do you declare static arrays? Integer, int array, 9 down to 0, integer, int b, 2 down to 7. So what is that you should notice here? It is possible to have MSB, most significant index, smaller than the lower index. It is possible. 2:7 is possible. 9 down to 0 is possible. Can I keep -2 colon 2? -2 colon 2. Is it possible? It is also possible. You can have indexes negative also. So in summary, this is also possible. Let me write down that. Possible. All are possible. Even for that matter, you can even write int d. So what does it mean? Same as 4 down to 0. When you give 5, you are telling that I want to declare an array whose size is 5 elements. Just take it up in the next one. So in summary, the index can be both positive, negative numbers. Okay, just size alone can be declared. What else? I think that's all about this. Let's do one array assignment. Can you please read this assignment, the one you see? Assignment I want you to. First, what should you do? Declare an array of word. Word means what? A 16-bit vector. 16-bit vector is called as word. Data type. What is the array size? 10, right? What should you do? Fill the array with random numbers between 20 to 30. Declare another array of word data type, same word data type, of array size how much? 10. Fill it with random numbers between 20 to 30. Same thing, whatever you did. Then write a logic to compare elements of the both arrays. Can you please do that now? Understood what is the question? You have to declare two arrays. Okay. You can call this as word array 1. You can call this as word array 2. Then you should write a logic to compare both the arrays. Why we are doing this exercise is to understand what improvements happened in system Verilog compared to Verilog. You may say this is Verilog question, right? Okay. What improvement happened? We are trying to understand. So please work on it. Those attending online, please post your answers. Whatever you do, you please post it in the chat window. Don't write down the question again. Don't write down the question. You will end up wasting 2-3 minutes. Rather, directly go with the answer. You have the printouts, right? Then do you feel writing two places will help? Will it help? Will you read two places? No, right? Just let it be there in your printed book. Just write the answer. Have you done it? Those attending online, have you done it? So good that you are able to make progress. Some of you who are not able to do progress, why I have taken your names is two things. Either you repeat Verilog, or in the evenings trainers will be available. You go to them, sit with them, and understand the problems. What is the problem you are facing? Basically, if you don't know how to declare an array right now, after telling what is the data type, then there is a problem, right? So you have to solve the problem. Either you repeat Verilog course entirely, or take the support. If you sit here without doing anything, nobody also cares. Okay. So please take that support. Next, let's do this one. Same thing for online students. The problem is in offline, at least I can come to you and check what is happening. In online, no response, nobody submits the answer. So I don't know who is doing what else. Okay, fine. Anyway, let's work on this. So what is the advantage of whatever I did just now in this file is TCS HRC is if I do SV new, it will automatically take me to that directory because I've given a command like SV new means this entire command. So if you just enter this command in terminal, it is like entering entire command. So advantage is what for me? Every time, let's say I close this, everything. I open a new terminal. I want to go to that folder. All I have to do is SV new. So it will take me to that folder. Even if it is very long, it will still take me. That one command will take me to this one. Okay. Now mentor. Session 2. Session 3. Let's make it session 3. Is it giving array 1 dot. What I want to do here, module top module. What is the first thing I want to declare? Array of word. Array of word. First you have to declare a word. What is word? Reg 15 down to 0. Go here. Reg 15 down to 0. Word array 1. What is the size? 9 down to 0. You could even write just 10 without anything. It will also work. But if you want a little more clarity, write 9 down to 0. What is the other one? 2. What is our requirement? Fill array with random numbers between 20 to 30. So let's fill it with 20 elements from 20 to 30. So how do you do that? Initial, begin, end. Okay. In Verilog, how do you fill it? Using for loop. In system Verilog, there is one more construct called as for each is there. What is the specialty of for each? Is you don't have to write the starting index, end index. it will automatically figure it out. Tell me, if I run a for each, where should it go from? What is the lowest index in that? 0. What is the highest index? 9. So like the way we are able to figure out lower index is 0, higher index is 9, the tool figures it out. You just have to say for each of word array, you have to tell which array you want to go through of I. Two things it does. First, it will declare I as an integer. You don't even have to declare integer I. The tool automatically understands that I is an integer. First thing. Second thing it does is it figures out what is the lower index, what is the higher index. It automatically goes through those indexes. So in this case, word array of 1 of I, index $u random range 20 to 30. You're giving a number between 20 to 30. What is the other one we want to do? Copy. Same thing you want to do for this two. Function is same thing, right? Fill the second array also with the 20 to 30 only. The array name is what? Word A2. Now what is that we want to do? Write logic to compare elements of both the arrays. So how can you compare both of them? Tell me. Will you use for loop or how will you do it? For loop, inside that you have to use if condition. So what will you do? Can I use for each here? Yes, we can use. So for each of A1, I'll write a comment, compare. If word A1 of I equal to word A2 of I. You understood? It's like comparing if A equal to B. Instead of A, I'm using word A1 of I. Instead of B, I'm using word A2 of I. You can display a message saying that for index equal to %0d matched. Else mismatched. Have you understood this code, line number 12 to 20? What this does is element by element comparison it does. In system Verilog, there is some improvement is there. In system Verilog also, you can do the same thing. Whatever you did now, you can do the same thing in Verilog as well as. The only thing is you cannot write for each, of course. What you can do in system Verilog is whole array comparison possible. Please read that statement. Whole array means what? The entire array can be compared to the entire array. All you have to do is if word A1 is equal to word A2. You get it. What am I doing? I'm just comparing the entire array with another entire array. Again, same thing. If they match, you can say entire array matched. Else case, what do you do? Entire array. Now, tell me if I'm generating these numbers randomly, will they match or will they mismatch? Sorry? 99.99% they will mismatch. Why? Because it can generate, there are so many combinations that there is a chance of only matching 1 out of some crore times. 1 out of 10 billion times. 1:1 to the power of 10 actually. The ratio of matching is only 1:1 to the power of 10. Because why? The first element can take any of the 10 values, 11 values. Second elements also can take any of the 11 values. So for it to match, all those combinations have to match. Okay. Anyway, let's not get into mathematics here. You got the idea, right? How to declare array, how to fill the array, how to compare the arrays. Yeah. It knows because you have declared it, it knows the lowest is 0, highest is 9. It knows. You have to write manually in that case. You have to write a for loop. Yeah. For each will go through each element. Like you're telling for each. Then how can you say half? You're telling for each. You cannot conflict, right? If you want to go through only half of the index, only till 5, you have to write for I equal to 0, I less than 5. Someone attending online has a question?
Sir, my doubt is that the dollar display you have written percentage 0D, and then you have not given anything as like the.
Oh yeah, that is a mistake. We have to give it. I we have to give. I we have to give. Next, if array mismatched, we can display both the arrays. Word array 1 is equal to how much? What should I write if I have to print everything in one line? Percentage P. Word array 1. Word array 2. I want to print them with some tab space, \T. Let's run this. See, they have mismatched. Entire array mismatched. So you see, first element is mismatching 25 and 30. Second is 24 and 28. You see that almost all of them are mismatching. None of them are also matching. And the same thing you can see here. Index 9 is mismatched, index 8, index 7, index 6, up to index 2. Only index 1 is matching. You can see 30 and 30 are matching. Except for this one, everything else is mismatched. So in system in Verilog, this is not possible. The whole array comparison is not possible. Have you all understood? Okay. This is one improvement that happened in system. The second thing is whole array copy is possible. Can you do one thing? I want you to copy, use whole array copy word A1 to word A2, then compare. Understood my question? I want you to copy word A1 to word A2 and then do the compare. Can you please write that logic? So two things I'm asking, I want to check. One, how will you do the copy? Very simple, one line, just. Do you really remember the logic that we implemented just now? The whole array compare we did, right? Okay. Then do whole array compare. Please do this. The idea is to check, are you really focusing the session? So let us do this. See, the whole array copy means word A2 equal to word A1. This is possible. You can copy entire A1 to entire A2 just by assigning it. This is not possible in Is it possible in Verilog? But it is possible in system. Then you know, right, compare logic. You know the compare logic. I have to copy paste this code here. What is the better way to do it? Tell me. I have to copy paste. Fine, GVim shortcut, I know. Instead of GVim shortcut, what is the best way to do as a program wise? From a Verilog language or system Verilog language perspective, what is the better way to do this? How can I reduce the code size? See, right now what I can do, I can copy Y8 and I just paste here. Same code, 2 places. What can I do to improve it? You can write a function. That's what task or function. So what can I do? Function void whole array compare. No arguments in function. It's written between function and end function. No need of begin end. In system Verilog, no need of begin end. So now wherever you want to do this, just do whole array compare. So then this code will not be required. Here also do the whole array compare. First I compared with random elements field. Then I am comparing after copying. So will it pass here or will it fail here? Pass, right? Why? Because you have copied and then comparing. So because both the elements have, both the arrays have same elements, they will match. Now I can try it. To understand the way, simplest way how function makes the code easier to work with. If you are using the same code multiple places, you declare it as a function. Call that function. First time it mismatched. Second time it matched. Same advantage. I mean, see, thing is, anytime you want to compare, you can just call the whole array compare. Now, this also I can write it as an individual element compare. I can write a function, even if I'm using one time only, I can still write it as a simple function. So for this also, I can write it as array element compare. What is the name of the function? Array element compare. You go here and just declare another function. Let's move this code there. Now, does this code look better to understand? The name itself tells you that you're doing the array element compare, you're doing whole array compare, then you're doing whole array compare. Like this, you can improvise the code. How it looks, you can improvise by doing small updates. It didn't take a lot of effort. We didn't spend a lot of time, but we can improve the code, how it looks. Okay. Have you understood this question? Okay.
Sir?
Similarly, yeah.
That function that you have written, in that you have used the dollar display, right? Dollar display is a system task. So wouldn't it like there's a rule, right? In the function, you can't use a task like that.
No, no, it's not a system task. It's a system function. See, those things dollar display gets over in 0 time. It is a system function like that. You can declare, you can call it as a system function, not as a system task. Instead of calling a system task and function, understood it as some functionality already implemented in the language. Don't go by the name system task. You would have used the keyword system task, but actually it's not a task. Dollar display is not a task. Is it clear to you?
So, is it only for system Verilog it's working like that, or in Verilog also?
No, no,
it is
everywhere
working?
it works. Everywhere it works. See, the common logic will tell you that, basic thing tell you that dollar display won't take any time. It will happen in 0 time. So then it is not a task.
Okay, sir. Okay.
Let's do one more question. String data type. Okay. Same question instead of word. You're taking same thing. Everything else is same. So let's do that also once. Okay. How do you declare a string in Verilog? Vector, reg vector, right? String is a reg vector. Based on the number of characters, you declare 8 into those many characters. Whereas here, how do you do it? I copy the same code. Okay. So in this case, very simple. There is a string data type in system. You don't have to worry about doing that calculation. How many characters will be there? 8 into those many characters. Simple. There is a string data. So this is the kind of improvement that happened in System Verilog. So what System Verilog does is it makes the coding easier. Like you see, array working with arrays is easier. Declaration of data types is easier. Okay, even string you can declare. You don't have to worry about declaring it like reg 8 into 25 down to 0 like that. All that you don't have to do. Just declare a string. Now when it comes to filling a string, did I give any comment how to fill it? You can fill it as string str1 to str10. So why we are doing this exercise is to understand how to work with strings in System Verilog. So there is a concept called as $s format f. $s format f or psprintf, both are same. str percentage 0d. Do you know what is 0d means? No space, comma I. What this does is assume that this is a display. If I is 1, if the value of I is 1, can you tell me what will be printed here? str1. str1, right? So here what will happen is, in this code, $display, as you know, it displays the value. $s format f doesn't display, it returns that string as an output. Let me again explain. If I use $display, what it will do? It will display the value. It will display the value as str1 or str2. When I use $s format f, it does not display, it returns as a string value. That whole str1 comes as a string that you are assigning to your string array. Instead of word array 1, use string array 1. Instead of word array 2, use string array 2. You got it right? Same way, here also you can use $S format F, str percentage 0D, comma I. Now, can you tell me what all elements will be there in this array? What will be the first element in the array? str0, because when I is 0, this will be replaced with 0. The value will be str0. Next element will be str1. So, you got it. So this is one of the important concepts in system Verilog, where you don't want to display, but you want to get a string which is variable. Now you may say, what about using this one? Can I do this? stri, because I is what? 0, 1, 2, 3. Will it work? It won't work, because it will take it as I only. It will not replace I with 0, 1, 2, 3. Our idea was to get, if I is 0, it should become 0. If I is 1, it should become 1. If I is 2, it should become 2. But this doesn't work. That is where System Verilog provides with a concept called as $S format F, where you have to use str percentage 0D I. Have you understood? Instead of that, also there is a concept called as PS print F. Both does the same thing. Either you use $S format F. F is indicating, see, S is indicating string. Format means do the formatting. F is indicating function. String format function. The full form, string format function. That is in short called as S format F. You can also write it as PS printf. Both does the same thing. Now if I display the elements of string array 1, string array 2, I can display. How can I display? You can write a for each string array 1, same code, and display them. How do you display? $display string array 1 of percentage 0D equal to percentage what? S. I'm printing individual lines. I'm not printing the whole array. You see, I'm not printing the entire array. I'm printing one element by one element. What is one element of array? String, right? So first I use I, comma, string A of I. Now if I run it, now no need to copy, right? Why? Because already both are same. Both are same. In any case, even you can do the whole array copy and compare. That whole thing will work. Now go to the run.do, change it to array 2. Here. Right. There is a problem, failed to open design unit file. Array 2 string, array str. Not array 2, array str. It is printing the elements. Index 9 has string 9, index 8 has string 8. All indexes matched, entire array also. So what are the few things we learned here? It is more than array. We learned how to work with strings in System Verilog. First thing is, declaration is very easy. So even if I, instead of str, if I use System Verilog something. Long name I used, I don't have to do anything. In Verilog, what I have to do? Immediately I have to go and write, resize the array, resize the vector. Even now it will work. If I run it, it still works. See, the big name came. So this is what System Verilog does. It makes the things easy. It doesn't complicate the things. It doesn't increase the complexity. It makes the things easy. because it wants to give more features, it adds more things like object oriented programming, dynamic arrays, functional coverage, which makes the our test bench development process easy. Do you understand what is $s formatf, $ps printf? You understand why we use that? Because every time we want a different string 0, str1, str2. How do you get it? You use an index, you write like a dollar display. Instead of display, replace with s format. So let us take a break. We will meet in 15 minutes and we'll continue after that.
This conference is no longer being recorded.
अबे क्या हो गया ये बेंच?
This conference will now be recorded.
Okay. So before the break, we were discussing about how to work with arrays. Majorly, how working with arrays is easier in system-level. Also, working with strings is easier in system-level. Now, let me introduce the new type of array, that is dynamic arrays. Dynamic array size is allocated at the runtime. Size can be changed during the runtime. How do you declare dynamic array? Int, integer or int DA, open and closing bracket with nothing in between. That is dynamic array. This is called as associative array. Either you keep a star. Star means the index becomes integer type. If I use string means index becomes string. What is index is? For every array, there will be indexes, right? Index 0, 1, 2, 3. In case of star, index is integer. If I write string here, index is string. This is a queue. Please note, it is not a queue because we wrote queue here. Even if you write XYZ, it is still a queue only because you wrote $. Do you all understand how to declare a dynamic array, associative array, and a queue? Right. So let's try one example. I want to declare an associative array whose index is byte, data type is string. Index type is what? Byte. Data type is string. How to do it? String associative array. Because the data type is what? String. Index type is what? Byte. The data type is string. The index type is byte. You may ask, what is index type? See, every array will have an index, right? If I take this as an array, this is index 0. This is what? 1. Index 2. So in case of associative array, it need not be integers. The indexes need not be integers. Like right now, we are numbering chairs as 0, 1, 2, 3, like that. For example, I have 10 chairs. I have 10 chairs. How will I number? 0, 1, 2, 3, up to 9. In associative array, it is not compulsory that you should number them as 0 to 9. You can name it as A, B, C, D, E, F, G, H, I, J, K, L. The first index will be what? A. It's not 0. Second index is what? B. So that is how it works in associative array. You may say, why do you want to do that? It's very easy with numbering only, right? There is a reason why we use associative array. We'll discuss that later. Okay, for now, have you understood what is different about associative array? Indexes can be any type. They don't need to be integers. They can be integer, they can be string, they can be a byte, anything for that matter. For now, let us only focus on the dynamic array only. Declare a dynamic array of word data type. Same question as what we did previously. Only thing is, it should be a dynamic array. Instead of using a normal array, what do we want to use? Use a dynamic array. So how to do that? Let's understand. what is the data type we wanted? Okay, instead of that, let's say if I write int data type, just to show you that we can have different possibilities. What is the data type I want? Int. So tell me what change I have to do in this code? Instead of this whole thing, shall I replace this or this whole thing? This whole thing, because instead of word, we want to replace with int. C, int. You want, you can rename the array also, word array, that also you can rename it. For now, I won't. What else I have to change in line number 2? What should I do? Leave it empty. Because we want it to be a dynamic array. Dynamic array itself means that don't declare the size. What change should I do here? Nothing. If you keep it nothing, it becomes dynamic array. The advantage of dynamic array is whatever size you want, you can at the runtime. See, initial will start at the runtime only, right? Initial code, when does it run? When you start the run. Initial code runs when you call the run. So that time you can give new of 10. So as per your requirement, you are able to allocate 10 elements. Later, somewhere else, I can resize it to 5, 20, whatever I want. The way I have allocated 10 elements, some other time I can reallocate it to 5 elements, 20 elements, or I can even delete the entire array also. You got it. Once you have done these 2 lines, everything else is exactly same. Once you have done this, everything else is exactly same. What does it mean? There won't be any difference here. There won't be any change here. No need to change any of that. Only thing is declare the array, allocate memory with as many elements as you want. Now, if you wanted, the advantage is now if you want 20 elements, into 20 elements. Will it work now? Yes, it will work. I'll just go run it. How many elements are coming in the array now? 20. If I only want 5 elements, 5, will come only 5 elements. So have you understood the difference? In fixed size array, during the declaration itself, you declare the size. In the dynamic array, you declare it as dynamic element, dynamic array. Later, using the new, you allocate the memory. Got it, right? You can use for anything.
Then what will be the vector size of the array?
No, see, you should not confuse those things. What are we doing is, this is like, you have to understand it like this dimension. Each entry will only have integer only. Each entry will be integer only. We are talking about dynamic in what sense? This sense. How many elements will be there is dynamic there. If you want, you can keep 5 elements only. If you want, you can keep 20 elements. That is what we are calling as dynamic. The size of each entry will remain int only.
If it is for range, so can we declare the size of the array?
If you want it reg, you declare it as reg only.
So then what is the vector size of the array?
Vector size is 1 only, because this side dimension is vector. This side dimension is array.
So that we can declare like 8-bit or 16-bit.
If you want, you can declare it. You can declare it as 7 down to 0.
But we cannot change dynamically.
That you cannot change. This you cannot change, but this size you can change. Understood? I've done the same question, $s format and all that. Here we are, instead of $s format f, we are using $s format. The difference is simple. S format is F means string format function. S format means string format task. You pass your argument there only. Difference is, I'll tell you in my code itself, you'll understand easily. Remove F. Whatever you had here, keep it inside here. Because it's a task, it will not return the value. Let me again explain. Instead of using a function, I'm using a task. S format means only task. This argument becomes the first argument. Rest all code is remains. Now, whether you use this one, whether you use this one, all three are exactly same. They're doing the same work. In my code, I use $s format. You can even use $s format F. This is about little bit about how to work with the arrays. Okay. So this will be part of the assignment. So please work on those. Now let's go a little bit into the Verilog language concepts. I mean, I'm not going to revise Verilog language. We are only going to focus on what are the shortcomings of Verilog language. What are the shortcomings? I mean, what is that? What drawbacks we have with Verilog language, and why we are moving to system. First thing is, Verilog language is a very simple language. What is simple language? Verilog language constructs. As you are aware, Verilog language can be implemented as behavioral, structural, or data flow level. Other than that, it can have module or compiler directives. Inside the module, what you can have? Always blocks. Always are initial. Inside that, you can further have task and functions. And then you can have procedural blocks. There you can have task function. Inside task function, you can have for loop, while loop, case statement. Then you can have for join. Other than that, you can have continuous assignment, system task, and functions. This is what majorly summarizes Verilog. System Verilog is little more than this. As I said yesterday, Verilog plus coverage, object-oriented programming, lot of other things. Now let us understand what are the Verilog shortcomings. And what is the problem with Verilog? First problem with Verilog is the first problem with Verilog is all data types in Verilog are static in nature. All data types in Verilog are static. What is the problem if all the data types are static? So I will tell you the problem with a simple analogy. Yesterday we took example of training room to understand what is static, what is dynamic. If this training room is static in nature, it means that only this batch training can be done here. No other batch training can be done because your memory is, this room is allocated to your batch. So no other training can be done here. If there are 15 batches running in the training at parallel, So how many training rooms I will require? 15 training rooms. If I make it dynamic, where in the morning I can use this for this batch, in the afternoon I can use for other batch. So how many rooms will be required? 7, 8 rooms are required. So which one is more efficient? Dynamic. Because in dynamic, what is happening is, in the morning 9 o'clock, I have allocated memory for this batch. Memory means what? This room allocated for this batch. Once this batch is done, I have deleted this memory. I have removed this room allocation to your batch. I will allocate the same room, that is same memory, for some other batch, because you don't need this room under. That is what is the advantage with dynamic data types. So, because all data types in Verilog are static, memory utilization will be very inefficient. Every time, second is, you have to always take into the consideration the worst case possibility for memory allocation. Means what? Again, in the same room context, right now there are 40 people. Tomorrow there might be 20 people. Next day there might be 55 people. Okay. Going by static, what static tells is, you have to always go with the worst case possibility. What is worst case possibility? What could be the biggest strength? 55. So you have to always keep 55 chairs here. Even if you use them, you don't use them, you have to still keep what? 55 chairs. That is static. What is dynamic is, if you want 20, today there are only 20 people, you know that 20 people are only going to come, I'll only allocate 20 chairs only for this. Tomorrow I know that there are 40 people, I'll allocate 40 chairs. So that number can be dynamically changed. So again, the same example, having a limited number of chairs, we are able to use them efficiently. That is the advantage of dynamic. In dynamic, what happens is, you allocate as much space as you want. Let's say after half an hour, some 5 people come. In dynamic, what do? We can increase the size from 20 to 25. We can ask someone to get 5 chairs and allocate those people. In static, what happened is, once I declared 20, means 20 chairs are done, you cannot increase that. Those 5 people will have to stand only. So that is the advantage. So the one advantage is what? Memory utilization is not efficient. And because of that, we always have to declare the worst case size. I mean, always need to declare the worst case maximum size. I mean, if I know that maximum strength can anytime be 60 only, I have to always keep 60. Even if 2 people come, I still have to keep 60 only. That is static nature. Next. That makes declaring complex transactions difficult. You always have to declare the worst case size. Second problem with Verilog is low level of abstraction. What is meant by low level of abstraction? Communication between components happens at a very low level. I'll give you one example. You have one component here. You have another component. Module 1, module 2. In Verilog, whatever you pass, you have to pass as a vector level only. 16-bit value, maybe 32-bit value, like that. You can only pass vector by vector. In System Verilog, there is a concept called as object. Is there in System Verilog? Object. We can group whatever we want to pass from one component to other component as one object. That whole object can be passed at once. Let's say you wanted to pass integer A, integer B, integer C, D. In Verilog, the only option is you have to pass A separately, B separately, C separately, D separately, A, B, C, D separately. Whereas in System Verilog, you can group all of them into some data type called as object, which will hold ABCD. That whole object can be passed from module 1 to one block to other block. It's not actually module, from one block to other block. So that is what we mean by low level of abstraction. In Verilog, you have to work at individual variable only, integer, vector, that level only. Whereas in system Verilog, you work at a bigger level where you group things as one unit. That whole unit is given from one component to other component, which makes the coding easier actually. The simple analogy is like if you want to move this table from here to here, the whole thing in Verilog, it's like moving this one remote separately, laptop separately. What system Verilog does is this treats the whole table as one unit, what we call as a class. This whole unit can be shifted there. That's how system Verilog helps. Next. Third is what? No pre-implemented data structures like FIFO and Q. Did we do FIFO in Verilog? Yes. Did we develop, or was it there in the language? Developed. Similarly, in system Verilog, you don't have to develop. Already it is there in language. If you want to queue, there is a queue behavior. If you want mailbox, there is a mailbox. So based on your requirement, you can use either choose a mailbox or you can choose a queue. Next, fourth reason. We are trying to understand the reasons why we are moving to system Verilog. You go to interview, or even personally yourself has to convince, right? Why am I learning system Verilog? Okay, till now you felt Verilog was good. You are able to develop designs. You are able to develop test benches. Then why we need a new language? So this is the answer for that. Fourth reason is difficult to build test bench for complex designs. If you have a complex design, in Verilog it is difficult to build the test bench for that. See, for simple designs like full adder, counter, SPI controller, asynchronous FIFO, they are all simple. Verilog is good to develop test bench for them. But when it comes to system Verilog, developing, so for complex designs, it's difficult with Verilog. That is where you need system Verilog. What is the fifth reason? No dedicated constructs for project progress tracking. In system Verilog, there is a concept called as functional coverage is there. What is that? Coverage. So functional coverage will tell you exactly how much verification you have done. If my manager asks me how much verification you have done, I will see what is my coverage number. Let's say coverage number is 74%. I can tell him I have done around 70% verification. In Verilog, you cannot really tell anything like that. You have to go by test case and tell after analyzing that. Next. The sixth thing. Module can't be passed as argument to the task functions, but object can be passed. What is that? Module can't be passed as argument to task and function, but object can be passed. This, let's understand what does it mean is, if I write a function print void I cannot write, if I have module something module sample I have, let's see. Is it possible? Can I declare module as an argument of a function? It's not possible, right? You agree with that? I have one module. For a function, module cannot be declared as an argument. Whereas same code if you take class sample. It is a class, it is possible. If it is a module, it's not possible. going forward, you'll realize that this makes the coding a lot easy. You're able to pass very complex things as arguments. The whole entry, see, if instead of passing, the advantage is what? Instead of passing int A, int B, int C, int D separately, of passing all of them separately, you'll have a provision where you group all of them into here, like you declare here int A, B, C. If you pass sample, automatically my code can access s1.a, s1.b, s1.c. So I don't have to pass individual thing. It is possible to pass the whole grouping of elements as a functional, which is not possible in Verilog. This is not possible. Since why it's not possible? Sample is a module. Module cannot be an argument, whereas class can be an argument. That makes the coding a lot easy. Tell me which one is easy? 52 line number is easy or 53? 52 is easier, right? That is the 6th point. 7th point is what? Reuse of existing code is not easy. In Verilog, task and function is the only way of reusing. How do you implement reuse in Verilog? Using task and function. System Verilog has a powerful concept called as object-oriented programming. That is much more better, much superior to task and function. In Verilog also, there is a concept of reusing. Whatever you want to call multiple times, you implement as a task and a function, you call that task and function. In System Verilog, you can do task and function. You can also use the concept of object-oriented programming, which is very powerful compared to task and function. So which we will discuss as we go forward. So these are the 7 reasons why we use System Verilog. What is the first reason? Static data types means Verilog only has static data type, which makes the Verilog very memory inefficient. Declaring complex transaction becomes difficult actually because of that. What is the second reason? What is it? Low level of abstraction, right? In System Verilog, you can do the things at a higher level. Okay. What is the third thing? No pre-implemented data structures, like no queue, no FIFO, no dynamic. I mean, a lot of things are not there. A lot of things need to be developed from scratch, like you did module FIFO, N module. That like that you have to develop. What is the fourth reason? Low level of abstraction, right? We said communication between one component and other component happens at a vector level only. Whereas when you come to System Verilog, it happens at a higher abstraction level that we have discussed. What else? Difficult to build test bench for complex designs. No dedicated constructs for project tracking. Module can't be passed as an argument. 6th, 7th is what? Reuse of existing code is not easy. Okay. So this is important because you say you have done System Verilog, you have done System Verilog project. The first thing someone will ask you is what? Why you are using System Verilog? So this is how typical Verilog code looks like. Module FIFO, inputs, outputs, all that. Then you can have while, reg, declaration, assign, initial, always, and task function. Going forward, you'll see that System Verilog code will be even easier actually. You don't have to worry about reg and wire. You don't have to worry about assign because all those things won't be there in a class. So I'll explain, I'll cover that as we go forward. Now let's focus on System Verilog language features. System Verilog is basically hardware description and verification language. What does it mean? When you say hardware description and verification language, what does it mean? It can be used for both design purpose as well as verification purpose. The Verilog language, system Verilog language can be used for both design purpose as well as for verification purpose. Verilog is called as what? HDL, hardware description language. It is majorly used for design purpose only, developing the Verilog design code only. Second is what? It is a object-oriented programming language. Object-oriented means what? Everything in system Verilog you view as a objects. You develop the entire code as an object. Going by that logic, I will call Verilog as what? Module-oriented language. Why? Because in everything in Verilog you develop as a modules. Like in Verilog, like everything you develop as a module. In system Verilog, everything you develop as what? Objects. And it is built on top of Verilog. That means what? Whatever is there in Verilog, it is there in system Verilog. Next. It has got constructs from Verilog, C, C++, and Vera. When I say the term construct, what is meant by construct? The language features, like dynamic array is a construct. Q is a construct. Int data type is a construct. String is a construct. Whatever language has, those things we are calling as in short as constructs. So where all those constructs are taken from? Verilog, C, C++, and Vera. Vera is a language which was developed by Synopsys 2 decades back for verification purpose. Vera is a language developed by who? Synopsys long back actually. So it has taken features from all these languages. So what it has, because of that, what it has got, compared to Verilog, it has got new types of literals, new data types, new operators, arrays, functional coverage, interface, lot of new things are there. Other than that, it has got inter-process synchronization concepts and the DPI. It also has static and dynamic constructs like class, dynamic array, mailbox, queue, associative array, semaphore, and cover group. Lot of new things. Please read through this list. Understood, right? Okay. So let's tell me what are the features. First thing is what? System Verilog is a hardware description and verification language. What is second thing? It is object-oriented programming language built on top of Verilog. Third is what? Features taken from C, C++, Verilog, and Vera. What is the fourth point? Static and dynamic constructs are there. I mean, whatever Verilog constructs are there, they have added new dynamic constructs. What is the advantage due to dynamic constructs? Memory utilization is more efficient. Wherever you use this, memory gets used efficiently. Other than that, it also has additional constructs for design purpose also. Like in Verilog, if you have to develop a behavioral code, what is that you use? Always block. See, sometimes based on the coding style, in Verilog, always block can infer combinational logic. Always block can infer sequential logic. Sometimes it also infers latch also. Based on the way you code always block, You can either get what? Combinational logic, sequential logic, or latch. So what does it mean? Always at the rate of A or B. Begin end. A, B, C in. A equal, sorry. Tell me, what does this logic will indicate? Combinational logic. Instead of this, if I use passage of clock, sequential logic. There is something else. Yesterday I was explaining you the 3x1 mux. If you develop like this, it will result in a latch. So the same always can infer a combinational logic, can infer a sequential logic, can infer a latch. And sometimes it's possible that your intention was combinational logic, but you ended up implementing a sequential logic, right? There is always such possibility, right? Your intention was combinational logic, but you got a latch. To avoid that confusion, system Verilog provides three variants. What does it mean? Always underscore combinational. I mean, your intention is to implement a combinational logic. What should be the last one? It gives us three variations so that you don't have any confusion. Your intention is to develop a combinational logic, use always underscore com. If your intention is to use flip-flop sequential logic, use always flip-flop. So Verilog does not have, but system Verilog has following. What are that? Always FF. Used to infer sequential logic. Com means what? Combination logic. Latch means latch-based logic. Many times, Verilog infers a latch in place of combination logic due to coding mistakes. You did a coding mistake, it infers something else. Those kind of things can be avoided by using this. You understood? Like this, not only for verification purpose, even from a design perspective, system Verilog has added newer things. There is a support for system Verilog. In summary, supports concept called as constrained random verification, coverage driven verification, assertion based verification, the complex scenario generation. Okay, so a lot of things are there, which is something we'll discuss as we go forward. Okay, did you get an idea of what is system Verilog constructs is all about? Features. Okay, this is how you can summarize the constructs in system Verilog language. Full red box, the outermost red box is what? System Verilog. As you can see, that whole box is the system Verilog. What is the small black box? Verilog, which is released in 1995. What is that green box? Verilog released in 2001. What is the dotted green box? C++. Means dotted green box, whatever is there inside that are the constructs from C language. These are the constructs from C or C++ language. You see, does C++ has a concept of class? Yes. Does it have inheritance concept? Yes. Strings? Yes. Int is there. Dynamic arrays is there. Associative array is there. But you see, these things are not there in Verilog. See, those things are taken into system Verilog. From C and C++ also they have taken things. What are the new things that are added which is not there in C and which is not there in Verilog? I circle now. They are not there in Verilog also. They are not there in the C++ also. Mostly they have been taken from which language? Vera. There is a language called as Vera. I mean some similar concept. So is it clear to you what is the system Verilog language summary? Towards the end of the course, by end of the course, you should get comfortable with these things. Anyway, you are all comfortable with many of these. You have to learn this additionally. I won't read it. Even if I read, you won't remember it. Okay. So just as we go forward, we'll be touching upon all these concepts. So So now let's start with the topic, literals. We'll do for another 10 minutes and we'll end the session. So literals, you know, right, in Verilog. What is literals in Verilog? How you assign the values? To a vector, you assign 0, 1, xz. To a string inside the double quote. That concept is what, how do you assign the values is what we are calling as the literals. What is literals? The rules followed in assigning values to the data variables. What are the integer and logic literals? 0, 1, x and z. 0 to f can be used for integer and logic literals in hexa format. Real literals is what? Fixed point format. What is string literals? Text enclosed in double quotes. Let's say if I write string name, to assign a value name, you have to put between double quotes. Text inside double quotes is the string literal. Can I write like this? Name equal to VLSI. It is a wrong literal. So these rules that we follow, the rules that we have to follow, right? See here, we are following a specific rule that it should be between double quotes. That rules is what we call as literals. What is array literals? You have to keep between flower brackets. Okay. There are different ways in which you can do. If I have integer array, what is size of this array? 5 elements. Which one is correct? The first one or second one? First one is correct. Is the second one correct? No. Why? Because you didn't use the flower brackets. So these rules is what we call as the literals. Mean in array literals, the rule says that you have to always keep between flower brackets. You can even keep nested flower brackets. That also we'll discuss. If I have integer a, can I assign this value a equal to 8 HP? It's not possible because p is not a integer literal. It is not a valid literal for integer. Is it possible? Yes. Is this possible? Yes. What about this? It is also possible, right? Because E and F are valid literals. Okay. But this one is not possible because P is not a valid literal. Similarly, for real literals, if I have to assign real C equal to 2, 3, is it possible? No. What I have to write? 2.3, 2.3. Time T. Okay, so fine. You understood the basic concept of literal, right? This we have discussed. Array literal I have discussed. Yeah. In multi-dimensional arrays, you can use nested flower brackets. Going forward, we will be discussing multi-dimensional array. That time I'll explain this concept. When there are multi-dimensional array, you have to use nested flower brackets. I will explain later. For now, understand that even this is also a type of literal which is used for assigning to multi-dimensional arrays. Like you see here, I have int multi-dimensional array. One dimension is size of 3, one dimension is size of 2. So you see, in the 3 dimension, I have 1, 2, 3, 4, 5, 6. So this becomes element 0, element 1, element 2. That is the dimension 3. In each dimension, I have 2 elements, 1, 2. 2 elements, 2 elements. Overall, what is the size of dimension? 3. That is this one. Inside each one, I have 2 elements. That is what makes it multi-dimensional array. It represents an array of 3 elements. Each element is again an array of 2 integers. Please read that statement. It represents an array of 3 elements. Each element is again an array of 2 integers. That's why it's called as multi-dimensional array. Array having an array. What is not correct? If you write 3, 2, you cannot give like this. Because you're only declaring one dimension. You're declaring only one dimension. Is this correct? Yes. So these are the rules which we are calling as literals. So this is a wrong literal for multi-dimensional array. Had it been one dimension, yes, correct. But if it is multidimensional, you cannot do that. Okay. Why literals are important? Literals ensure that all language users follow the same guidelines. Means if these are implemented as a rules, everyone will follow the same rule. Otherwise, what will happen? I will follow my own rules. Everyone, some other person will follow his own way of implementation, which will go wrong. So literals ensure that all language users follow same guidelines while assigning values to the data variables. Like int a equal to p, int a equal to 10. So I may say a equal to p is correct, but it is not correct, right? Because there is nothing like p. This is about literals. So we can stop here.
This conference is no
If you
longer
want, we
being
can
recorded.
continue. If everyone is okay, we can continue. What is that you prefer? We can continue for another half an hour also. You're okay to continue? Yes, everyone? Fine. Okay. Let's
This
discuss
conference
about
will now be recorded.
let's discuss about the data types. So before this, what we were discussing? Literals. So we discussed about integer literals. What are the integer literals? 0, 1, x, z. Then we discussed about what? Real literal. Means you have to use point, 2.3, number point, oh, number. What else? Time literal, array literal, string literal, multi-dimensional array literal. You got it right? What is the concept of literal? Okay. There could be other data types also which has its own literal rules. You have to understand this concept. Okay. Now we'll move to the next topic, data types. In system Verilog, there are more data types compared to Verilog. Tell me in Verilog, what all data types did we study? Integer, time. Only these things. Even string is also not there. String is a reg vector. Let's say I call it a string, which is nothing but. This is all what is there in Verilog. In Verilog, what all things we discussed? Integer, time, real time, string. System Verilog has a little more bigger list. If you come to System Verilog, there are things like struct, union, enum. Okay. What else is there? Event. Event is there here also. Okay. What else is there? There is a very important concept called as user-defined data type. User can define their own data types. Class is of course one more thing. C handle, class. So these are the new data types added in Verilog. So one which come from Verilog, and those which are added in system Verilog. So what we are going to do is, we are going to divide all those data types into two categories. The one which are simple, which we know from Verilog language. What are those? Integer based, void, and string. Then the other category. For next 1 week, we will only learn the basic ones. Because if I start introducing enum, struct, the user-defined data type, it will be a bit confusing. So we'll focus on the basic ones now. Then we will learn object-oriented programming, because to learn object-oriented programming, this is sufficient. Once it is done, then we'll move to the complex data type. For me, ideally, my goal is actually to complete object-oriented programming. But without teaching these fundamentals, I don't want to go. First, I want to make sure that you're good with the basic data types. How to declare an array, some basic things like what is integer, what is int, okay, what is byte, what is logic. There are a lot of such things are there. What is a string? Then we'll go to object-oriented programming. Once it is done, then we'll do these topics. Okay. So first, let's start with the basic data types. Integer-based data types. In Verilog, what all integer-based data types are there? Only one thing is there, one or two, just integer. Other than that, you can declare reg vector or net vector. These are the three things which will give you integer behavior. What is the first thing? Integer itself. Second is what? Reg vector or net vector. In System Verilog, there is a big list actually. Why also we'll discuss. I mean, you may say, why not just integer? Why do we need other things? We'll discuss that. Okay. First, let's talk about integer-based data type basics. Integer-based data types can be differentiated based on following four aspects. First, you need to know the size of the data type. Whether it's a 8-bit data type, 16-bit, 32-bit, or 64-bit. I mean, whether that data type will take 8 bits only, 16 bits, or 32 or 64 bits. Second is state data type or 4-state. 2-state means it only takes 0 and 1. 4-state means it takes 0, 1, x, and z. I mean, it can have possible values as 0, x, 1, x, and z. Third is signed or unsigned. You can also declare some variable as a signed variable. You can declare it as a unsigned variable also. The fourth one is Verilog based, or is it added in the System Verilog, newly in the System Verilog? What is this concept? If I go to the next slide, you will understand. See, there are a lot of integer-based data types in System Verilog, which are not there in Verilog. Many of them are not there in Verilog. So we are trying to understand how do we differentiate them. One is based on the size, number of bits it takes. One is based on the 2-state or 4-state. One is based on whether it's signed or unsigned. One is based on whether it is inherently present in Verilog or is it added newly in System Verilog. So this table will summarize that. If you take first 3 categories, what is the difference between them? All of them are int only. Long int, short int. What is the difference? Only the difference is the number of bits. What is meant by 2-state? It can take 0 and 1 only. Even if you assign x, what it will store it as? 0. Okay, let's understand that through one example. Int a, integer b. We are trying to understand the difference between int and integer. What is the difference? Int is 2-state, integer is 4-state. So both are around 32 only. Only difference is 2, 4. What is the other difference? Integer is there in Verilog, int is added in System Verilog. If I go here, initial, begin, end. Something like this assigned. What did I do? Assigned ZX0Z44. B also I'll assign the same thing. B also I have assigned the same. So tell me if I display it. Tell me what will be displayed for A, what will be displayed for B. Can you write it in your notes? If I display A, display B, what will be displayed further? So what will be displayed? A will be displayed as what? Tell me. 0, 0, 0, 0, 0, 4, 4. What about B? Same. Because B being an integer, which is 4-state variable, can hold Z, can hold X. Whereas A being a 2-state variable, when you give Z and X, it will store it as zeros. Got it, right? Now, what is the difference between short int, int and long int? Only the difference is in the size. Why you need short int, why you need long int? Int is sufficient, right? Why you need them? Because again, memory efficiency, memory utilization efficiency. Let's say you know that you have one variable whose value is always between 0 to 100 only. Some variable is there whose value is always between 0 to 100 only. Do you really need int? Because it can go up to 2 to the power of 32, which is very big. So for you, short int is sufficient. In fact, not only that, you can even use byte. See, byte is a 8-bit, same concept, but it's a 8-bit. Because if it is 8-bit, value can be from minus 127 to 128. That is there, right? One of them, minus 128 to 127. That. Okay. So if you know that the value is only from 0 to 100, it can never go beyond that. Instead of declaring them any of that, you declare it as what? Byte. That way, how much memory you save? You save 24 bits of memory. If you use int, it will take how much space? 32 bits. Instead of that, if you use byte, it takes how much space? 8 bits only. Right. Next. Let us understand the difference between byte and bit. Tell me what is the difference? You can see clearly here. Assume that here 1 is there because bit is by default 1. If you declare a bit vector, it will have a different size. That's why they didn't give any size. You can declare a different size bit vector also, right? So hence they didn't give any size. What is the only difference, major difference? One is in terms of the size, one is in terms of the signed and unsigned. Let's understand the difference between signed and unsigned nature. Module top and module bit A, byte B. So this also, let's make it as 7 down to 0. Are both of them same? Are both of them same? They are not same. They are different. Why they are different is, answer is here. Tell me, what is the difference? Signed and unsigned. What is difference between signed and unsigned is, it can store Actually, the range is from where to where? Minus how much? 128 it will go, right? To 127. 2 to the power of 7 it can go, right? Isn't it? 2 power 8. Okay, 128 to minus 127. This will be the range. This will be the range. The range is from 0 to 255. That is one difference. Second thing is, you can see here only. Even if you assign a negative number to A, it will store it as a positive number only. It means what? Even if I write A equal to minus 20 and B equal to minus 20. If I do dollar display, A equal to what? Percentage 0D, A, B. What will be printed for A?
235.
Print as 235 because it will convert minus 20 into 2's complement. See, during the storage, what it will do? It will convert minus 20 into 2's complement. Can you do that? 2's complement of minus 20. I want you to write the 2's complement equivalent of the minus 20. And you know the size is how many bits? 8 bit. So in a 8-bit format, show me the 2's complement value of minus 20. So what is a 2's complement? It will be. So how do you get it?
हाँ
20 is what? 0, 0, 0, 0, 1, 16, 0, 1, 0, 0. This is 20. What is minus 20 in 1's complement? 1, 1, 1, 0, 1, 0, 1, 1. That is 1's complement. What will be the 2's complement? Plus 1, it will become what? 3 will become 4, right? That is 2's complement. This is the 2's complement. B also same thing. There is no difference. B also same thing. But after this, the difference will come. The difference is that because bit vector is a unsigned in nature, it treats this one as a absolute value, not as a signed bit. Because A is unsigned, it won't have any special meaning for 1. It won't treat it as signed or unsigned nature. Whereas B being a signed variable, this 1, the MSB 1, it will use it for a signed calculation. Understood the difference? In one case, it will treat it as a 127 actually. A will take it as a 128 to the power of 7th bit position. It will take it for magnitude calculation. Here, it will treat it for signed or unsigned nature. So, if you add up this whole thing, it will become what? 128 plus 64, 192 plus 32. How much? 226. Right? Plus some 10, 236 it will come. You understood? Whereas here, since it treats it as a signed nature, it will be printed as minus 20 only. If I run it, one it prints as 236, one prints as minus 20. You understood the difference, right? Why is it so? Have you understood the logic? That is the difference between bit and byte. Logic and bit and logic we'll discuss as we go forward. The difference, as you know, is one is 2-state, one is 4-state. Reg and logic, the way I look at it is, reg is used in the design purpose when you are coding a module to represent a register variable. To implement the behavioral logic code, we use reg. Every other place we use logic. Real and short real, you know, real is bigger size. Short real will be, I think, 32-bit size or something. We can check the size. You also know the difference of real time and time. Real time will give you the time in real format, that is in floating point format. Time will only give in integer format. So this is the difference. Okay. Now talking about 2-state and 4-state variables, we have discussed the difference. Same thing. If I assign 10ZX, A will store it as 10ZX, B will store it as 10000. We have discussed this. Signed, unsigned, I have explained you. What if we want to declare bit-based variable as signed? I mean, can I make A also a signed variable? Is it possible to get signed nature from this? It's possible. There is a concept. There is a keyword called as signed. You have to use that signed. When you use signed, now A becomes a signed variable. So because you have told that it's a signed variable, this one will be used for what? Signed nature. So what will be A printed? Minus 20. If I run it now, both will print as minus 20, minus 20. Reverse also I can do. What is reverse? Byte is signed. I want to make it. What should I write? B automatically becomes unsigned variable. Signed, unsigned, you can change all that. Okay. So SV provides signed and unsigned keywords to change the inherent behavior of the data. Signed variable, you can change it as unsigned. Unsigned variable, you can change as signed. Time and real time, we know. Time prints, if I display this, you go through this code. I have a module top time A, real time B. Okay. Initial begin hash 1.3, that is 1.3 unit delay. If I get A equal to $time, what will be stored for A? It will round it off. It will round it off to nearest integer. A store only integer value. B is what? Dollar real time. So display, when you display, it will store it as 1.3 only hash, given that you have taken this. This is important. This is important. Only then 0.3 will be taken as valid. Okay. What will be printed for B? 1.3. So let's run this code. I run this. One is printing 1.0, one is printing 1.3. Whereas same code,
काम कर पहुंच के कॉल करना
if I use precision as 1ns, tell me what will be printed? A will be 1 only. What about B? 1 only, because precision is 1. You don't have any concept of 0.1, 0.2. 0.3 will be rounded off to 0, because you are taking a precision of 1 nanosecond. You don't have any lower precision. So in this case, what will be printed? Both will be printed as 1.0, 1.0. So that is why precision is important. You should know, you should use the right precision. Int and short int. Int takes 32 bits. Short int takes 16 bits. If we know some variable value will always be less than 1000, then what can we, then that can be declared as short int. Byte can hold maximum value of 127. Range is from -128 to 127. It's not actually -127. It's -128 to 127. Byte unsigned is range from 0 to 255. What is the range of short int? -2 to the power of 15 to 2 to the power of 15 minus 1. That is the range of a short int. What is the range of bit 7 down to 0? Because it is unsigned, it is from 0 to 255. Okay. We will, in the next session, we'll continue with the other system Verilog data types. So any questions till now?
This conference is no longer
We'll end
being
the session.
recorded.
क्या भाई सब